we're told to look at the rational numbers below, order them from least to greatest. They really didn't have to tell us this first sentence. I would have known to look at the rational numbers to order them from least to greatest. Well, anyway, they tell us 1/2, -5, 3.3, 0, 21 over 12, -5.5, and 2 1/8. So the easiest way to visualize this might just be to make a number line that's long enough that it actually can contain all of these numbers, and then we can think about how we can compare them. So let me just draw a huge number line over here. So take up almost the entire screen. I'll stick, let's see, we have some negative numbers here. We go as low as -5.5. And we have some positive numbers here. Looks like we go as high as 3.3. This thing is still a little less than 2, so we go about as high as 3.3. So I can put, I could safely, I think, put 0 right here in the middle. I could go a little bit to the right since we have our negative numbers go more negative. So 0, and let's make this -1, -2, -3, -4, -5. And, well, that should be enough. -5. And then in the positive direction, we have 1, 2, 3 in the positive direction. And let's see if we can plot these. So to start off, let's look at 1/2. Where does 1/2 sit? So it sits, let me make the scale a little bit better. So this is 1, 2, and 3, and 4. All right, so let's start with 1/2. 1/2 is directly in between 0 and 1. It is half of a whole. This right here would be 1 whole. This would be 1 whole. Let me label that. This over here is 1. So 1/2 is directly between 0 and 1. So 1/2 is going to sit right over here. So that is, let me write that a little bit bigger. You probably have trouble reading that. All right, 1 over 2, which is also 0.5. So this is also 0.5. Anyway, that's where it sits. Then we have -5. -5, well, this is -1, -2, -3, -4, -5. -5 sits right over there. And then we have 3.3, positive 3.3. I'll do that in blue. Positive 3.3. So this is 1, 2, 3. And then we want to do another 0.3. So 0.3 is about a third of the way. A little less than a third of the way. It'd be 3.33333 forever if it was a third of the way. So a third of the way, that looks like about right over here. This is 3. This right over here would be 3.3. And let me label. What I'm going to do is I'm going to label the numbers on the number line up here. So it's 1, 2, 3, 4. This is 0. -1, -2, -3, -4, -5, and so on and so forth. And then we get to 0, which is one of the numbers that we've already written down. 0 is obviously right over there on the number line. So I'll just write this 0 in orange to make it clear it's this 0. Then we have 21 over 12, which is an improper fraction. And to think about where we should place that on the number line, let me do this in this blue color. To think about where to place it on the number line, let's change it into a mixed number. It makes it a little bit easier to visualize, at least for my brain. So 12 goes into 21. Well, it goes into it one time. 1 times 12 is 12. If you subtract, you get a remainder of, well, we could actually we could regroup here or borrow. If you don't want to do this in your head, you would get 9. But let's do it. Let's do this. So if we borrow 1 from the 2 becomes a 1. This becomes 11. Or we're really regrouping a 10. Anyway, 11 minus 2 is 9. 1 minus 1 is 0. So we have a remainder of 9. So this thing, written as a mixed number, 21 over 12 written as a mixed number, is 1 and 9 twelfths. You get 1 12/12 in there, and then you get 9 twelfths left over. So 1 and 9 twelfths, we can also write that. Actually, we could have simplified this right from the get-go, because both 21 and 12 are divisible by 3. But now we could just divide 9. We can simplify 9 twelfths. Divide both the numerator and the denominator by 3. We then get 1 and 3 over 4. 1 and 3/4. And just to make it clear, I could have simplified this right from the get-go. 21 divided by 3 is equal to 7. And 12 divided by 3 is equal to 4. So this is the same thing as 7/4. And if you were to divide 4 into 7, 4 goes into 7 one time. Subtract, 1 times 4 is 4. Subtract, you get a remainder of 3. 1 and 3/4. So going back to where do we plot this? Well, it's 1, and then we have 3/4. So we're going to go 3/4 of the way. This is halfway. This is 1/4, 2/4, 3/4 would be right over there. So this is our 21/12, which is the same thing as 7/4, which is the same thing as 1 and 3/4. And then we have negative 5.5. Negative 5.5. I'll do that in magenta again, running out of colors. Negative 5.5. Well, this is negative 5. So negative 5.5 is going to be between negative 5 and negative 6. So let me add negative 6 to our number line right here, just to make it clear. So let me go a little bit further. Let's say that this is negative 6. Negative 6. And our number line will keep going to smaller values. Scroll to the left a little bit. Negative 6. So then if we go to negative 5.5, it's smack dab in between negative 5 and negative 6. So this is negative 5.5 right over there. And then finally we have 2 and 1/8. I'll do that in orange again. Well, I'll do it in blue. 2 and 1/8. So it's 2 and then 1/8. And so if we want to find the exact place, we could divide this into eighths. This would be 4/8. This would be 2/8. And that would be 6/8. And then 1/8 would sit right over here. So that right over there is 2 and 1/8. So we've actually plotted as best as we could the exact locations. You didn't have to plot the exact locations if you were trying to just order them, but it doesn't help. It doesn't hurt to see exactly where they sit when we order them. So now we've essentially ordered them because we stuck them all on this number line. The order is negative 5.5 is the smallest, then negative 5, then 0, and then positive 1/2, then 21/12, then 2 and 1/8, and then 3.3. And we're done.